Now see the question number 14. What is the resultant magnetic moment of the magnets each of magnetic moment M in the following figure? In the first figure, two magnets kept in mutually perpendicular. In the second figure, three magnets are kept making a triangle. And in the third figure, two magnets are oppositely oriented. And the fourth figure, two magnets are kept making an angle 60 degree. The first option is root 2m, 0, root 3m and 0. Second option, root 2m, 0, 0, root 3m. Third option, root 2m, root 3m, 0, 0. And the fourth option is none. Now see how to solve this problem. In this, there are four different sets are given. In the one set, this is one magnet and this is another magnet, north and south, south and north, and this angle here 90 degree. This is the first. And the second diagram, magnets are oriented like this. This is a triangle in the form of a triangle. And south, north, south, north, south and north. And the third diagram, magnets are kept like this. Two magnets oriented like this, south, north. This is south and north. And in the fourth diagram, two magnets are kept in this manner. This is south, north and south and north. And the angle between these two is here 60 degree. So we have to check what is the resultant magnetic moment of all these three. See, as we know, magnetic moment is a vector quantity. So we have to take the vector addition. See, in the first, south pole and north pole, magnetic moment direction is always from south to north. South to north this is south to north this. Each have magnetic moment M and M. The two magnets and their magnetic moments are mutually perpendicular. So resultant for first resultant is your magnetic moment your root 2m. For second, B, south to north, this is one, then south to north, and then this is your south to north. These three are a cyclic vector. When the cyclic vectors are there, so resultant will be your always 0. So for B, the resultant magnetic moment will be 0. And the C, one magnetic moment in this direction, another in this. So these two also are equal and opposite. So in the C option, resultant is also here 0. Now in the D, two vectors, one M here, another M here, and these two are making an angle 60 degree. So resultant magnetic moment. So when the two vectors are making an angle theta, so resultant value can be given as by relation under root of a square plus b square plus 2ab cos theta. In the same way, m square plus m square plus 2m square and cos 60, that is your 1 by 2. So this will be your root 3 times m. So as per the given option, in the option 2, first is your root 2m, second is 0, third is also 0, and fourth is root 3m. So correct option is your option number 2. Question number 15. The question is given as two short magnets of equal magnetic moment is fastened perpendicular to each other as shown in the figure. The magnetic induction at a distance d from the center of the magnet at P is. The first option your mu naught by 4 pi m root 5 by dq. Second option mu naught by 4 pi 2m by dq. Third option mu naught by 4 pi m root 2 by d cube, and the fourth option mu naught by 4 pi 2 root 2 m by d cube. Now see, here two magnets are kept mutually perpendicular. This is the one magnet. Both are your short bar magnet like this. So here and the point P is somewhere here. That point P at d distance from the center. So what is here? Main point is the P point is the on axial point of this magnet and equatorial point on this magnet. As we know, if we are talking about this is the magnetic moment direction for this bar magnet. So due to this magnetic field direction, you have B1 in this direction. B1 is due to the magnet which is along the line joining the point P to the axis. So B1 value is nothing. It is given as mu naught by 4 pi 2m by d cube on axial point. Same point P is in equatorial for this magnet. This is the magnetic moment direction for this magnet. As we know, on equatorial point, magnetic field is your opposite to direction of magnetic moment. So magnetic moment in this direction. So magnetic field B2 will be in this direction. So B2 is equal to your mu naught by 4 pi m by d cube. So these two fields are mutually perpendicular. So resultant field is B1 square plus B2 square. After solving, you will get mu naught by 4 pi root 5 m by d cube. This is the resultant field. So now come to the see the result. BR is the root 5 m by d cube, or option number 1 is the correct option. In the question number 16, a bar magnet of magnetic moment M is equal to 2I plus J plus 3 cap is situated in a uniform magnetic field of magnetic induction B is equal to 5 J cap. The torque experienced by it has a magnitude of. The first option your 5, second option 5 root 13, third option 25, and the fourth option your 10. So the magnetic moment of a magnet is given as M is equal to your 2I plus J plus 3K cap. 2IK plus J cap plus 3K cap, and magnetic field on which this bar magnet is kept is given as 5J cap. So as we know, torque is defined as M cross B. So cross product of M with B. So we can get cross B is 5J cap. Now simplify. I cross J your K. So 2 into 5, 10. I cross J your K cap. J cross J 0. And K cross J is your minus I. 15 I cap. So modulus of torque is your root over 10 square plus root over 15 square. So this is your 100 plus 225, so 325. This is the cross product, and magnitude and then if after simplifying, this will be your 5 root 13. So this is the correct option. So answer is your 5 root 13. So correct option is your option number 2. So hence second answer is the correct answer. Question number 17. To work done in rotating the magnet from the direction of uniform field to the opposite direction to the field is W. The work done in rotating the magnet from the field direction to half the maximum couple position is, first option your 2W, second option your root 3 by 2W, third option W by 4, 2 minus root 3, and the fourth option your W by 2, 1 minus root 3. In the question, first they are saying the work done in rotating the magnet from the direction of uniform field to the opposite direction to the field. See, it means let this is the magnetic field direction. So initially your magnet is your in this direction, initial direction M. Now this is the initial, and in the finally the magnet is your in this position. This is the final. So work done in doing this. So work done is equal to your negative of the or change in potential energy. Work done is equal to negative of change in potential energy by the conservative forces. See, so this written as minus U final minus U initial. The U final is this situation. U is your minus MB sin theta cos theta. U is your minus M dot B or minus MB cos theta. So initially final position your magnetic field and magnetic moment making angle 180. So U is equal to your MB minus of initial theta here 0. The minus become plus MB. The total work done we can see 2 MB, which is given as W. In the second case, this is your first situation. In the second situation, they are saying find the work done in rotating the magnet from the field direction to half the maximum torque. See, so initial position in the first year same. Initial position in the first year same. This is the initial position, B and M. But torque as we know, MB sin theta. So torque maximum for theta is your 90 degree and half of the maximum torque. So torque maximum by 2 will be for theta is your, when sin theta your 1 by 2, so theta is your pi by 6. It means now the angle between magnetic field and magnetic moment makes an angle 30 degree. So here, then work done W dash is equal to minus U final. Final is this, and relation is your minus MB cos theta. So minus MB, theta is your 30, the cos 30 your root 3 by 2. And initial theta is your 0, initial theta 0, the cos theta is 1. So 1 and 1 become your plus minus here MB. So now when we are substituting this is your minus, and MB we can take outside, and in the bracket you will get 2 minus root 3 by 2. This is the new work done. Now substitute the value of MB from here. Initially MB minus MB is your W. So minus MB is written as W by 2. The minus MB or W by 2. This will be your W by 4, 2 minus root 3. So this is the new work done, and this is the same as we got in the, so correct option your option this 3, which is saying W by 4, 1 minus root 3. Question number 18. The question is given as the magnetic induction at a point due to short magnet varies as. First option 1 by D, second option 1 by D square, third option 1 by D cube, and the fourth option 1 by D to the power 4. Magnetic field due to short magnet. This is the magnet. Let there are two situations, we can say a point P which is at distance D, and in another case we can say this is the point P which is also at distance D. So this is called your axial position, this is called equatorial position. So B on axial is given as mu naught by 4 pi 2m by D cube, and B on equatorial is given as mu naught by 4 pi m by D cube. So we found in both the expression B is inversely proportional to D cube. So B is inversely proportional to D cube, and this is the same option as option number 3. So our correct option, your option 3 is the correct answer. The question number 19. A bar magnet of magnetic moment M is cut into two equal pieces and they are arranged as shown in the figure. Find the resultant magnetic moment of the system. The first option here, root over M by 2 whole square plus M by pi square. Second option M by 2. Third option M, and fourth option M by pi. As per the given question here, initially the bar magnet is this, and this have length L, and magnetic moment M is given as M into L. M is the pole strength. Now this divided into two parts. This cut into two parts. One part have length L by 2 and another has been made semicircular like this. So see, if we are talking about this part and this part, this is the length here L by 2 and radius of this here let R. So pi R is equal to your L by 2. So radius R is your L by 2 pi. So magnetic moment here, this is the one magnetic moment M2. This is one magnetic moment M1. So M2 is equal to M into 2R. Distance from here to here 2R, to 2R. So this is 2R is your M, L by pi. This is M2, and M into L is the initial M. So this is your M by pi. Similarly, if I am talking about M1, M1 is your M into L by 2, so this is nothing, M by 2. So we are having two magnets, one having magnetic moment M1, M by 2, another having magnetic moment M2, M by pi, and direction of the area are mutually perpendicular. So resultant magnetic moment is M1 square plus M2 square, and this can be given as root over M by 2 whole square plus M by pi square This is the resultant magnetic moment. So option number 1 is the correct option. Question number 20. Two identical north poles, each of pole strength m, are kept at the two corners A and B of an equilateral triangle of side L. An isolated south pole of the same strength m is kept at the third corner C. The resultant magnetic induction at the third corner C is the first option mu naught by 4 pi m by L square. The second option root 3 by 4 pi L square into mu m. Third option root 2 mu naught m by 4 pi L square, and the fourth option is 0. As per the question here, there are three corners of an equilateral triangle. In the A, pole strength m, B also pole strength m, C pole strength here minus m. Equilateral triangle, it means each has sides length here L. Now, we have to find magnetic field due to A and B and C at C point. At C point due to A, field here in this direction, BA. Due to B, field here in this direction, BB. An angle between these two is 60 because this is your equilateral triangle. Since the pole strength is same as well as distance from C is also same, so magnitude of BA and BB is your same, which is your mu naught by 4 pi m by L square. This is the magnitude of the force. Now angle between this is 60 degree. So resultant B is your BA square plus BB square plus 2BA BB cos 60. So cos 60 or 1 by 2. So this become root 3 BA. So which is your root 3 times mu naught m by 4 pi L square. This is the answer of resultant magnetic moment at point C. So root 3 mu naught m by 4 pi L square. So option 2 is the correct option. Question number 21. The chemical formula of natural magnet is the first option Fe2O3, second option Fe2O4, third option Fe3O4, and the fourth option your Fe2O2. So this is the question directly based on the memory, and so the option number your 3 Fe3O4 is the correct option. Fe3O4 is the natural magnet, natural chemical formula of magnet. Chemical formula of magnet. So answer your option number 3 is the correct formula. The question number 22. A thin bar magnet of length L and magnetic moment F is bent at the midpoint so that the two parts are at right angle. The new magnetic length and magnetic moment are respectively. See, as per the question here, initially the length of the magnet here L and their pole strength here minus m and m. Now, the magnetic moment initially we can say m into L. Now these are bent in the form of right angle like this. So minus m and m will be here. This is L by 2. This is also L by 2. So this length This length is called magnetic length and magnetic moment in this direction. So magnetic length now become magnetic length is equal to your L by 2 whole square plus L by 2 whole square. So this is your L by root 2. This is the magnetic length. And magnetic moment, the new magnetic moment M dash is your M into L by root 2. So this is your M by root 2. So magnetic length will be your L by root 2, magnetic moment will be M by root 2. So correct option, your option number 2 is the correct option. The question number 23, the magnetic moment of a bar magnet of length 20 centimeter is 3.6 into 10 power minus 6 ampere meter square. The magnetic length is 90% of its geometrical length. The pole strength is the first option 2 into 10 power minus 5 ampere meter. Second option 1.8 10 to power minus 4 ampere meter. Third option 7.2 10 power minus 8 ampere meter. And the fourth option 0.55 into 10 power minus 4 ampere meter. Now magnetic moment is given as M into L. Here magnetic moment value is given L. L is the magnetic length, which is here given 90% of the total length of the magnet, and a small m you have to determine. So m is given here, m is equal to m. This is your 90%. 90% of total length of magnet. Total length of magnet. Now capital M, magnetic moment is given 3.6 into 10 power minus 6. That we have to determine. 90% means 0.9. Total length here 20 centimeters. That can be said as 0.2 meter. So now M is 3.6 10 power minus 6 by 0.18. So this is nothing, it is the your 2 into 10 power minus 5 ampere meter. So this is the correct answer. The option number 1 is the correct answer. Question number 24. A bar magnet of magnetic moment M is bent in the U shape such that all the parts are of equal length. The new magnetic moment is the first option M by 3, second option 2m, third option root 3m, fourth option 3 root 3m. See, initially a bar magnet is given, length here L, this is the pole strength minus m plus m, magnetic moment here m into L. This is the pole strength and magnetic moment m can be written as small m into L. Now it bent into the 3 equal part and the U shape. So let this your S, now south and north. So one like this. It bent in this form. So this is your L by 3. This is also L by 3. This is also L by 3. Now this is your south pole and this is your north pole. So this is the effective length of this, and this length here L by 3 and pole strength here M and M minus M. So new magnetic moment M dash is equal to M into L by 3, and M into L is your capital M. So this is your M by 3, then your capital M by 3. So your correct option is your option number 1. Question number 25. The question is given as, when a bar magnet is placed at 90 degree to uniform magnetic field, it is acted upon by a couple which is maximum. For couple to be the half of the maximum value, it is to be inclined to the magnetic field at an angle is first option 30 degree, second option 45 degree, third option 60 degree, fourth option 90 degree. When a magnet is kept in magnetic field, the torque on the magnet is written as mb sin theta, where theta is the angle between magnetic moment and magnetic field. So for maximum torque, for torque maximum, theta should be 90 degree, and that torque maximum is nothing, m into b. Now when torque is your half of the maximum torque, now if torque is your 1/2 of torque maximum, then angle we have to find mb sin theta, and torque maximum your mb by 2, 1/2 is equal to your sin theta, so theta is 30 degree. So our correct option here, option number 1. So option number 1 is the correct option. The question number 26 is this: a bar magnet of magnetic moment M is bent into a shape S with all segments are equal. Its new magnetic moment will be first option m by root 3, second option m by root 5, third option m by root 2, and the fourth option 2m by root 3. See here. So bar magnet is like this. L is the length, and minus and plus m are the pole strength south and north. So magnetic moment here m into L. Now it is bent in the form of a S shape like this, and it is given S shape, the total length 1, 2, 3, 4, 5. So each length here let L dash. So 5 L dash is equal to your L. So each L is your L by 5. So here it is your south pole having pole strength here minus. This is your north pole, pole strength here plus m. This is your minus m, this is your plus m. So magnetic moment direction here from negative to positive. This is the magnetic moment m dash. So first we have to find this distance. This distance let L double dash. The magnetic moment m dash is your m into L double dash. In L double dash, this is your L dash plus L dash. It means 2L dash, and this is a L dash. The L double dash is your root over 2L dash square plus L dash square. So this become your root 5 into L dash. So L dash your L by 5. So this is your L by root 5. So magnetic moment is written as into m. So m dash is equal to your L by root 5, and m into L is equal to your initial magnetic moment m. So this become your m by root 5. So new magnetic moment after making a shape S become your m by root 5. So our correct option here, option number 2. So answer 2 is the correct answer. Now see question number 27. Two north pole each of pole strength 8 ampere meter are placed at the corner A and C a square ABCD. The pole that should be placed at B to make D as a neutral point is. The first option, north pole of pole strength is 8 root 2 ampere meter. Second option, north pole of pole strength 16 root 2 ampere meter. Third option, south pole of pole strength 8 root 2 ampere meter. And the fourth option, south pole of pole strength 16 root 2 ampere meter. Now see the question here. A square given ABCD. This is a square ABCD. Let length is here L. And it is given A, B, C and D. It is given two north pole kept at A and C. North pole means positive. And these two north pole having some pole strength at D. So at D, due to C pole magnetic field in this direction and due to A in this direction, and these two are equal B1 and B1 because magnitude of pole strength and distance are same. Now, what should be the pole strength at B so that the D is the neutral point? So what we will get? We will find the resultant of B1, B2. The resultant of B1, B2 your B1 square plus B1 square means root 2 B1. And root 2 B1 means root 2. B1 means mu naught by 4 pi. And M by L square. This is the value of your BR. And this direction your this. So, to make neutral at D, we have to put another pole of pole strength M dash. That M dash must be your negative because this M dash should produce the magnetic field in this direction, which must be opposite to BR. Then the point, this will be neutral point. So, this BR dash, let that can be said as BR dash. So, BR dash must be equal to your mu naught by 4 pi M dash by this whole distance. This is your L, this is also L. So, this will be your root 2L. The root 2L whole square. And for a D point as a neutral point, as point D is a neutral point, so BR dash must be equal to your BR. So mu naught by 4 pi M dash by 2L square must be equal to mu naught by 4 pi and BR is your M by L square. Now when we are substituting the values, so M dash is your 2M. So pole strength, the pole strength of B must be equal to your 2M and M is given here 8. M is here 2, 8 your, and this is your 16 ampere meter. So pole strength of pole at B should be your south pole and the pole strength will be your 16 ampere meter. So this is the correct option. So BR. So BR value will be here. BR dash is your mu naught by 4 pi M dash by 2L square and BR is your mu naught by 4 pi M by L square into root 2. After that, when we are simplifying, so we are getting M dash by 2 is your root 2 into M. So M dash is your 2 root 2 into M. M is your 8. That is 16 root 2 ampere meter. So the pole strength of pole kept at B point should be 16 root 2 ampere meter and that pole must be your south pole. So our correct option, your option number 4, which is given as a south pole of pole strength 16√2 ampere meter. Question number 28. A magnetized wire is bent into an arc of circle subtending an angle 60 degree at its center. Then its magnetic moment is x. If the same wire is bent into an arc of a circle subtending an angle 90 degree at its center, then its magnetic moment will be the first option, your x root 2 by m. Second option is x by 3. Third option, your 2 root 2 x by 3. And the fourth option, your 3x by 2 root 2. Now see, like this. This is a wire, and this wire have length L, and their magnetic moment can be said as m into L. Now they are saying it is bent in the form of a circle which subtend an angle 60 degree at the center. Then magnetic moment your x. So we can get this value. Let radius your r. So pi by 3r. This is the arc length equal to your L. So r is 3L by pi. This is the radius. Now poles are here. So if we are talking about the effective length, this is L dash, L dash. So x is equal to your m into 2L dash. X is the magnetic moment when they are making angle 60 degree at the center. So this is your m, L dash. This is your r, this angle your 30. So L dash your r sin 30. So 2 L dash your r sin 30. So x is equal to your m into r, and m means ml into 3 by pi. This is the value of x. Now in second case, this we can say the first case. First case is this. In the second case now, this arc is making an angle 90 degree. This angle your 45, this is also 45. So radius now changes. So radius let r dash. So new magnetic moment m dash is your m. R dash cos 45 and r dash cos 45. 2r dash cos 45. So root 2m r dash. Now we will find the r dash value. Total angle pi by 2, so L. L is equal to r dash into pi by 2. So r dash is your 2L by pi. R dash we can substitute here. R dash 2L by pi. So this is your 2 root 2 by pi into ml. So now we can substitute the value of ml by pi. ml by pi your x by 3. So ml by pi is your x by 3. So 2 root 2 x by 3. The new magnetic moment m dash is written as 2 root 2 x by 3. So our correct option, your option number 3 is the correct option. So hence we can say the third is the correct option. Question number 29. A bar magnet is placed with its north pole pointing north. Neutral point is at a distance d from the center of the magnet. The net magnetic induction at the same distance on the axial line of the magnet. The first option 2BH, second option 3BH, and third option BH, fourth option 7BH. See, as per the question here, let first we can define our direction: east, west, north, south. Now the bar magnet is placed with its north pole pointing towards north. This is our bar magnet. This is north pole. This is the south pole. Magnetic moment here this. So this is the direction of magnetic field here, like this, due to the bar magnet. Now it is given neutral point is at distance d from the center of the magnet. Now when we are talking about the neutral point, see, lines of forces will be like this, in that manner, and it may go like this. Lines of forces may go like this. Earth magnetic field here in this direction, BH. So this is the d distance. So due to the magnetic field B, due to earth magnetic field BH, so these two are making an angle here. These two are making a neutral point here. So we can say B here, mu naught by 4 pi capital M by d cube. This is the B value, which is equal to your BH. So magnitude of magnetic field due to bar magnet and due to earth horizontal component, both must be equal and opposite, then we will get the neutral point here. So this is somewhere here neutral point. Now they are talking the point which is on the axial line is this. This is the axial line. Same distance d. This is your same distance d. If we are looking the magnetic field here, due to the magnet B dash, due to earth BH. So net field at axial point. The net field at axial point. At axial point, that your B net is equal to your B dash plus BH. B dash is your mu naught by 4 pi 2m by d cube plus BH. Now, as we have derived earlier, mu naught by 4 pi m by d cube. Mu naught by 4 pi m by d cube your BH. So 2 times means this become your 2BH and plus BH. The net field is your 3BH. This is the resultant field on the axial point. So our correct option here, option number 2. Question number 30. A bar magnet of magnetic moment M1 is suspended by a wire in a magnetic field. The top of the wire is rotated through 180 degree and then the magnet rotates through 45 degree. Under similar condition, another magnet of magnetic moment M2 is rotated through 30 degree. The ratio of M1 by M2 is the first option 1 by root 2, second option root 2 by M, third option 1 by 1 and the fourth option 1 by 3. Now in the first case it is given here torque. Torque is equal to your MB sin theta. Now it is given as, in the first case it rotates by an angle 45 degree. Although the torque is same, since torque is same, M1B sin theta 1 is equal to your M2B sin theta 2. M1 B, and in the first case the rotation is your 45 degree, sine 45, M2B sine 30. So M1 by root 2 is equal to your M2 by 2, so M1 by M2. M1 by M2 is equal to your 1 by root 2 or 1:2. So this is the ratio between magnetic moment of a bar magnet. So our correct option, your option number 1 is the correct answer.